So I'm going to be demonstrating the test for normality to meet one of the assumptions in the two-sample t-test. You can see here that we have two sets of data. We have the people in our first condition, who we have 20 individuals, and here are all their scores. And in the second condition, we have 18 individuals producing these scores. Um, so all this is doing is testing the assumptions which are necessary before we do any statistical test. And I already tested the assumption for this sample, and I'll show you what this looks like, and then I'll show you how to do it for the second sample. The first thing we looked at in step one is to create a histogram to look for outliers. And I've done that right here. And we can see that we have, a little bit of, a gap here. But remember, those normal distributions don't always look very normal. We don't have 30 individuals. We don't know about the population, but yet I think this one is going to qualify as normal. But me thinking that isn't quite enough. And so let's go on and get the QQ plot. And I've done that as well. And I can see that this QQ plot does look like it has some little bit of deviations from normality, but it doesn't look awful. So let's see if it's good enough. It does show some departure from the normal curve is how I described it here, with indications of both kurtosis with the S and with skew with those tails diverging. The next thing we do in step three is our first test. We just use Excel to calculate kurtosis and skew. I've done that, and you'll remember the threshold for kurtosis. Both of these need to be near zero. The threshold is a little more generous for kurtosis. We're looking for scores, ideally we want less than 1 for kurtosis, and for skew, ideally we want less than 0.5. We do meet both of those criteria. So according to this little test, it looks like it's going to be normal. And the last thing I did, and I did it right within connecting the QQ plot, is what we call the Shapiro-Wilk test, which basically takes into account both of the kurtosis and skew, but in a more robust way. And it generates a test statistic that ideally we want to be very near to 1. 1 is a perfectly normal. And we want our significance test to be non-significant. So when we look at our test significance, we see that this is 0.96. It's within that acceptable range, close to 1. And the significance level, the p-value, remember, for it to be significant, it would have to be less than 0.05. This is greater than 0.05, so greater than 0.05. We see we have the 0.63, and so this also would be normal. What that means is, if this is the distribution, right, we're testing whether, so this represents normal, and our sample score is represented in this test statistic. And we can see that the p-value shows that, if this is the cutoff point for 0.05 and our shaded region is over here, we can see that our test statistic, 0.96, is falling. Our W statistic is falling here in the fail region. And in this case, this is where we want it to be. We will actually fail to reject the null. It's got a p-value of 0.63, and we needed a p-value of 0.05. So we'll fail to reject HO, and we find that our sample does not differ significantly from normal. So that is what we're doing in a nutshell. Now let's look at how to do this yourself for another sample. And I'm just going to insert some cells so that we can do this at the front. So here I'm going to grab these scores. The first thing we're going to do is, first thing we're going to do is copy these. So that we can start our test for normality with sample 2. So step 1, we're going to create a histogram to look for outliers. So let's go ahead and grab the data. and create the histogram. This is on our insert menu, and we'll go down not to this bar chart, but to this histogram. You'll find that we're going to get only 3 bars, which are not very informative. So this is the histogram. We can put it where it belongs and even make it a little smaller, but we need to add some more bars. So to do that, you'll just need to click down there on the x-axis. Let me show you again. Take your cursor and click right over these numbers on the x-axis, and that should highlight it. Once that's clicked, keep your cursor there and right-click, format the axis, and you'll see this come up. It might be on this. If so, you need to click over here on this graph and just give it more bins. I always arbitrarily give it 10 bins. There's not a super good reason for doing that. You should have 8 or more. And now we see that we have more meaning in our data. We could see that this doesn't look very great, does it? It looks like it's a bimodal distribution. It looks like there might be some weird kind of skew. So maybe this one won't be normal. Let's do some more tests. Let's go ahead and do the QQ plot. So I'll grab so interpretation. Let me say, this appears to be bimodal and possibly skewed. Worrisome. Okay, let's go ahead and get the step 2 for sample 2, which is the QQ plot. So in order to do that, we'll use our tool. I'm going to grab our data here. We're using this, whoops, we're using this, uh-oh. Let's see if I can fix that again. Sometimes when you accidentally click on a cell, as I just did, then oh, there it is. Okay, we've got our person 1 score back. Just click in the top cell, hold Control Shift down arrow is really the easier way, so you don't run into problems like that. And here is our QQ plot generator, which I've cleared up. To use the tool, go to Paste Upload Data. You can see that, first off, my data do not have a header. And let's go ahead and just paste our data. You'll get something like this in yours. Just click your cursor in there, ignore all the stuff that's in there, and hit Control V to paste. And then click on Import Data. And now you can just scroll down and you will come to a place where you need to select the column. So right here where it says select column and options, just select the only column that's there, column 1, and hit generate QQ plot. Now, if we scroll on, we'll see the QQ plot and what it looks like. Remember, they lay it out a little differently than the demo I gave in class, but conceptually it's just the same. So don't worry about titling it or anything. Let's just grab this table. You can download it if you wish to in one of these ways. I actually just take a screenshot because we're really just doing this for an activity. This is what our QQ plot looks like. So I'm just going to copy this and put it right into the spreadsheet, and then we'll take a look at it. So here we go. That's kind of big. I want it to be a lot smaller. So let me just drag it up here like this. All right. And this is sample 2. Clarify that as well. All right. So this one doesn't look too bad in my estimation. None of them are ever going to be perfectly on the line. We have a little bit of a hint of maybe, a skew here on this one. We've got sort of an S shape. I'm going to just say there is a hint of skew at the lower end. And something of a bulge at the center. It doesn't look perfectly normal, but may still meet the criteria. So we can do something like that. Step three, then, though, since we're a little uncertain right now, is to use Excel to calculate skew and kurtosis. We'll just get a general hint that way. It's a really simple calculation, equals kurtosis, KURT, and let's select our data. We get a minus 0.56, and for skew equals skew. And let's see what number we get here. All right. And now remember what we want. We want both these numbers to be near to zero. So the lower, the better. In kurtosis, if it's considered normal is less than one. It's iffy if it's higher than one, but not too bad. And this is for kurtosis. And for skew, normal is less than 0.5. And we can see that we meet both of these criteria. So let's just write a little interpretation here. Both skew and kurtosis are near zero. Let's see, kurtosis less than one, and skew less. I'll just write the less than sign because of the space. These are within the range considered normal enough. And let's do our last test. Let's do the Shapiro-Wilk test. And we've actually already done it because if we scroll down in our tool that we used here, let's put this up here. We scroll down in the tool that we've just used, we can find the test of Shapiro-Wilk. And if we go down here, we can see all kinds of good information. I mentioned earlier that the way that Excel calculates skew and kurtosis is slightly different from the way they do it in this app, but we should get similar results. At least the direction should be the same. And if it's low, if it passes the test in one app, it'll likely pass the test in the other app, but with slightly different numbers. All right. So we look here and we look at our test statistic. We see that the Shapiro-Wilk test statistic W is 0.9586. So let's put that in there. W equals 0.9586. And let's look at the significance. And we could see that the significance is 0.5745. If we were pasting it into a chart, we know that we would be, that this would be a fail to reject the null hypothesis. The test, the p-value is well above 0.05, which is the threshold we use, just like we do in just like our alpha that we use in statistical testing. And this test statistic, remember, if it's above, it's got to be near to one. The test, let's just write W. W is near to one and within the acceptable range. Remember, if it's below 0.9, it would be a problem. So I'll write above 0.9. And so for all of these reasons, I'm going to indicate that it appears that we can feel confident that our distribution follows a normal enough pattern. We can do a statistical analysis with it because it follows Even though it looks weird, it does meet the criteria that are established in the discipline for normality.